Hello, my name is Abdulrahman Sufyan, international student from BEKM, and this is group 14. Mohamed Anwar, Mundir Yusuf, and I are going to continue presenting part D and E. So in part D, we have talking about power measurement. We have a simple circuit with 240 AC source and load Z. Could be a resistance 230 or capacitive 10 or 50 millifarad, also inductive 1 Henry, 1 millihenry, and 10 millihenry and 50 millihenry. So in a part A, we have like simple circuit with sources 240 AC and 50 hertz, and the phase is 90 degree. We have also here multimeter to help us to measure the AC, the current and voltage. And based in the graph here, we can see that the current is 1.04 and the voltage is 240. So it can be entered in I and V are in the phase. Both achieve their peak in a positive value and zero value in the same instant. So that means the phase difference between I and V is zero. Moving to part B here, the Z load is like capacitive load with 10 millifarad and 50 millifarad. This is for the 10 millifarad and this for the 50 millifarad. So because the capacitor storage energy, they can increase apparent voltage in the same circuit. So the capacitive reactance XC decrease, which is lead to increase the current in the circuit. Moving to part C, Z is inductive load here. We have like 1 Henry and 1 millihenry, 10 millihenry, and 50 millihenry. So this is the same circuit, just we change the resistance to inductor, where here 1 Henry and here 1 millihenry and here 10 millihenry and here 50 millihenry. Those the graph for each circuit, and we have here's like the measurement for current and voltage. So when inductance of inductor increase, the maximum current will decrease. Also the voltage leads current by 1/4 of the cycle or 90 degree phase angle. This is all about A and part B, C. So Mundir will continue in a part D and E. Thank you.
Hello everybody, my name is Mundir. I'll be continue explaining question D, part D and E. So part D for question D, resistor and capacitor in parallel. So as we can see here, this is the resistor and also this one the capacitor in parallel. We put here the capacitor 10 mF and we calculate in the graph. Here is the time and the voltage, and here is the tabular. Okay, here is start at 0 and stop in 10 seconds. The point is 100. Here we change the resistor is still the same, 230 ohm, and the capacitor we change it to 50 mF, and also in parallel. Okay, here is the phase. Here is the phase 90, and also here is the hertz 50. And we calculated this is the graph, and also here the voltage graph, and here is the time. This is for part D. This one for part D, transit simulation. For part E, resistor and before that, we need to calculate the impedance. The impedance for part D. This is the calculation, as we can see here. Here is the resistor, 230 ohm. And here is the 50. So the impedance is 0.318 ohm. This one for the first one. The second one is same rule. So it will be a 0.0637 ohm. So for part E, resistor and inductor in parallel. First one was resistor and capacitor. Now resistor and inductor. So how we will do? Here is the resistor and here is the inductor. First one will be 1H, second one will be 1mH. Will be start at 7, will be start at 0 and end in 10 seconds. Okay, buoyance is 100. Buoyance is 100. Okay, here is the time graph. Here is the voltage graph, and this one is the parallel, the tabular graph. Now, when we change the inductor to 1mF, all of them will be changed. As we can see, here is 50 mF. There's 50 mF. This one 230 ohm. Also here the calculation impedance for part E. You can see. This is at 230 ohm resistor parallel with 1H inductor. First one. Second one with 1mH inductor. Third one will be with the 10mH inductor, and everyone it's valued here. So the fourth one will be 50 mH inductor. Thank you so much. This is all for question D.
Assalamualaikum, my name is Mohamed Aunar. So today I'm going to present about part E for lab 3. So I've been instructed to do the delta-delta connection and Y-Y connection, which is I'm presenting right now is the delta-delta connection for my group. Okay, this is the setting for the whole circuit. For the delta-delta connection, we use a few commands right here, below here. And this is the setting for the voltage source. Amplitude is 120, frequency 15, 50 Hz, and the degree is the difference of 120, which is this is 0, 120, and 240. The difference is 120 degree. So the impedance right here is all the same. So if we show the graph, by selecting the graph, you can see that the current value for all these three phase right here is all the same, which is about 0.6 something right here. Yeah. So next, I will simulate for the voltage supply or voltage source. One and 5. Okay. As I noted here, N001 and N005, only these two shows the amplitude of 120 volts, which is the full or the max voltage. So if we go to the manual calculation, you can see that this is the max voltage. One of it is not shown in the graph due to the grounding right here. Okay, right here, due to the grounding here. Then the current, the max current, which is the phase current right here, it is around 0.6 something. So the simulation value for the delta-delta connection is equal to manual calculation value for this connection. Okay, next I will go to the Y-Y connection. Okay, this is the setting for our Y-Y connection. As we can see, the angle difference for all these three voltage source is the same like delta delta connection, which is 120, and the impedance value is different from the delta delta connection, but for these three phases is all the same. For example, this R1, R2 and R3, the value is the same, and for the L1, L2 and L3, the value is also the same. So impedance value for these three phases is the same. So if we do the graph, we simulate the graph, we can see that we can see that the value for all three all three load is almost like 5.3 or something like that. So by doing the same impedance value, the phase current will be the same. It is like 5.3 something, right? So I will go to the wire connection manual calculation and show the value. Okay, this is the current load. Okay, the phase current. Okay, so it is 5.3 something, all of it. The difference only the angle. So the impedance value, the same impedance value will resulting the same value of the phase current for each phases. So next I will simulate for the max voltage source. Okay, before that, we also use the command right here below here for this circuit. Okay, next I will continue for the max voltage simulation, which is I have noted here N001, N003 and N006. So we'll do N001, N003 and N006. Okay. This is the result. So the max voltage for all these three probe is 120. So then we will go to the manual calculation. Okay, for YY connection. As we can see from this figure, the value for all three of the voltage supply is around 120, with the phase difference of 120. Okay, before I forgot, I will mention about the error log. We will go back to the delta delta connection. Okay, here is the SPICE error log for the delta delta connection. It shows the current max for the R1, R2 and R3, which is around 0.6 plus minus, and also the max voltage for the N001 and N005, which is around 120. Okay, next I will go for the YY connection, its error log. Okay, as you can see right here, the current max for the V1, V2 and V3 is around 5.4 something, which is around the 5.3 like before from the calculation. So it is have some minor difference. Then the max voltage is around 120 volts, which is the same as the manual calculation. So from here, I can conclude that both of this connection, its manual calculation and simulation value is the same. I think that's all from me. Thank you.